In a nutshell, the core mission of an integrated management information environment is to provide required technology capabilities for reuse. A true IMIE is requirements-driven, uses architectures to inform available capabilities and gaps, and exploits modern collaboration tools and proven open-source methods to rapidly deliver solutions. Because the technologies used in an IMIE are a consequence of specific requirements and not the latest shiny object or conference buzzword, an IMIE, when adopted, evolves efficiently, exposes costly stovepipes and redundancies, and provides many opportunities to significantly reduce both direct and indirect technology costs. For cloud computing evangelists, the IMIE's strong reliance on requirements and program management, identity architectures, reuse, and user experiences show the critical path to cost savings because all IMIE technology capabilities reside in the cloud. We have no local servers or software we depend upon because we only use those capabilities the DoD provides as a service to anyone connected to their network. As one of the top users for the last 2 years, the IMIE is a major contributor of configuration management requirements for software, platform, and infrastructure as a service capabilities it consumes in DoD, and has received many awards from these providers for our solutions and approach. The earlier versions of the IMIE were devoted primarily to adding foundational technology capabilities such as modeling and simulation, data acquisition and storage, visualization, online analytical processing, and document management, workflow, and collaboration. The first IMIE released focused on delivering mostly domain-level solutions to fill immediate gaps within organizations. For example, in the IMIE 1.0 release in December 2009, we implemented our requirements process, identity management, and a point-of-entry architecture, along with process automation, all using available Department of Defense enterprise platforms and services. During 2010, in IMIE 2.0, we added enterprise collaboration tools, solution architectures, and we also delivered a wide variety of business technology solutions ranging from performance metrics automation to telework, IT investment management automation and reporting, and military awards end-to-end process automation. Today, IMIE solution architectures can deliver end-to-end process design and automation, web solutions such as training portals and reporting tools, and data standards and application frameworks that can all be shared and reused as the government sees fit. With the release of IMIE 3.0, we're bringing all these capabilities together in the context of a proven requirements process and collaborative program and lifecycle management methods to demonstrate the potential for federal information technology acquisition and management reform. Speaking for myself, I believe the old methods of managing and delivering technology at an enterprise level are extraordinarily costly and inefficient, and somewhat akin to a boxer leading with his chin and not his fists. However, even though an IMIE can provide the tools and methods to create a government that works better and costs less, it will still take fighters, both government personnel and contractors, who are willing to step in the ring and fight for reducing costs. The heroes will be those who, by deed, do whatever they can to eliminate their jobs. President Kennedy said, "Ask not what your country can do for you, ask what you can do for your country." I have always staked my professional reputation and quality of life on that level of commitment to our nation, and I hope others watching this video will join me too. Anything can change when you're committed to doing the right thing, and I think it's time for us to do the right thing. I hope you enjoy the following short video, the IMIE in a nutshell.
Hello, I'm Luke Skywalker's hand. As you can see, I survived a major cut. Ha 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 ha. The concept of cloud computing has been around for many years. With the introduction of personal computers into business and consumer markets more than 3 decades ago, some of the earliest clouds were private local area networks in companies where a community of users for the first time were able to share a variety of services such as email, print, and file storage. Immediately following the emergence of these private clouds, we saw internet service providers such as Prodigy, CompuServe, and America Online begin to dominate consumer markets. These early consumer clouds were subscriber-based, used the telephone connections, and offered gated online communities that provided a broad array of services such as email, instant messaging, message boards, and chat rooms. As ISPs expanded, the emergence of e-commerce and other financial services gave birth to online advertising as a new source of revenue. It may surprise some of you to know that AOL's original vision, engraved on the corporate headquarters wall in Virginia, was to build a global medium, the Internet, that would be as central to people's lives as the telephone and television, and even more valuable. Back then, it seemed like crazy talk to a lot of people outside the company. Now, only 15 years later, I think it's fair to say that Steve Case's AOL vision was achieved even though his company is no longer the owner of it. The first corporate local area networks and the evolution of the Internet service providers that sparked the beginning of the World Wide Web offer as many clues into the possibilities of the 21st century cloud. As security risks associated with today's online identity management capabilities continue to rise, new solutions, products and standards, and techniques will continue to rapidly emerge that will increase demand for more trusted and secure services. Virtualization and standards-based development frameworks that were not available in the early days of the Internet now permit scalability to a marketplace that today spans the entire world. Across the globe, consumers today already spend hundreds of billions of dollars on technology each year to get what they want from companies that profit from the delivery of those services because they continually innovate and improve their products and services. Sadly, this is not the case in our own federal government. According to a recent report released by the White House on February 8, 2011, quote, "The federal government's current information technology environment is characterized by low asset utilization, a fragmented demand for resources, duplicative systems, environments which are difficult to manage, and long procurement lead times. These inefficiencies negatively impact the federal government's ability to serve the American public." The report was issued by the U.S. Chief Information Officer appointed by President Obama. In 2011, U.S. taxpayers can expect to spend more than $80 billion on technology capabilities to deliver services for our nation. That cost does not include the cost of not adopting technology to perform functions and deliver services more efficiently. Nearly half of that spending, about $37 billion, will occur in the Department of Defense. And IMIE provides one alternative for anyone not seduced by the dark side to champion better government at a lower cost. Please enjoy the remainder of this presentation, and may the Force be with you.
The IMIE is a cloud computing environment that consists of proven methods and techniques to manage enterprise requirements, architectures, capabilities, and rapidly deliver high quality and scalable solutions to any enterprise, public or private. The IMIE is not a set of tools. It is any enterprise environment that provides realistic opportunities for a vast network of people and communities to connect and work collaboratively to perform digital missions and operations from any location that is connected, accessible, trusted, and secure. In an IMIE, I can walk up to an ATM nearly anywhere and get cash money, deposit a paper check into a machine without talking to a person, or transfer funds electronically using a plastic card and 4-digit passcode to virtually any place in the world. I can hand a total stranger a piece of plastic in a foreign country and pay for my purchases. I can go on the web and buy anything I want on any website and have it shipped directly to wherever I want it sent in the world overnight. And I can reach in my pocket, press one button on a mobile phone, and see everything I've spent in real time and pay all of my bills with one click 24 hours a day, 365 days a year, without printing any paper or signing in ink. I can do all of these things and more, along with hundreds of millions of other people in different states and countries around the globe at the same time with little or no latency or downtime. I don't have to have anyone set me up or train me, and I can use a computer, television, phone, game console, or just about any other device to stay connected. The IMIE concept of operations is a comprehensive approach that guides the design and delivery of cost-effective, high-performance enterprise technology solutions, spanning all phases of the project development lifecycle, from initial feasibility analysis and conceptual design through implementation and enhancement. The IMIE concept of operations provides a proven method for managing enterprise technology investments through an efficient requirements process that uses solution and enterprise architectures to baseline, evaluate, develop, and measure technology capabilities and gaps as portfolios, while also delivering rapid and scalable high-quality solutions to problems today. At its foundation and potential for scalability, the IMIE concept of operations represents a global web-based business operations capability that can be fundamentally transformed the United States federal technology enterprise at all levels by delivering focused and cost-effective management of technology investments. Of course, in practice, an IMIE must be flexible and scalable to any enterprise, both large and small. For instance, in our IMIE, requirements are managed, clarified, using standards and architectures that inform available capabilities that are shared. Gaps are filled by services through configuration management, and solutions are presented in the cloud. Welcome to Getting Started with the IMIE. The mission of an integrated management information environment is to provide technology capabilities and architectures for reuse across a federal enterprise. The purpose of this presentation is to familiarize business personnel with the requirements gathering and solution design steps of the IMIE concept of operations that precede a technical capabilities assessment. In accordance with the IMIE concept of operations, upon assignment of an R or requirement that includes the name or topic of the requirement, objectives or desired outcomes, and any resource and prioritization guidance that generally accompanies these types of requests, the following actions are undertaken. Step 1. Complete due diligence. Due diligence is defined as the use of reasonable but not necessarily exhaustive efforts that a prudent person might be expected to perform in the examination and evaluation of a requirement, capability, or proposed course of action. In some cases, the identified requirement is not defined enough to be evaluated against available capabilities, and additional information such as scope, functionality, and intended impact must be collected from stakeholders in order to begin design. There may also be formal governance bodies and staff that need to be informed or involved to develop requirements in advance of a capability assessment. Due diligence is the planning step that takes place prior to approval to begin design. It is a vital first step under the IMIE concept of operations that allows early detection of common issues in advance of a design effort. The desired output of due diligence is either approval to begin design or a decision to delay or cancel the design phase based on the information presented through due diligence. To organize for due diligence under the IMIE concept of operations, it is helpful to develop and identify an initial plan of action and milestones that shows the scope of the problem to be solved, that includes but is not limited to identifying the name or topic of the requirement or request, the objectives or desired outcomes of the project or request, for example, what problem is being solved, the implementation sponsor, resource and prioritization guidance, the initial participants or stakeholders that should be involved in the design, project management channels and protocols that will be used during the course of the project to monitor progress and collaborate, and any approval governance to include the names of the person or persons who will approve the final design before development is started. One of the major flaws of using conventional development methods, and a frequent problem in formal organizations, is that the executives who ultimately approve the final designs are typically not involved in the due diligence phase that shows the feasibility of a project or program early on. Sometimes design efforts are resourced and initiated by subordinates without completing any reasonable due diligence at all. In extreme cases, executive decision makers may not be briefed until the development has been completed and the solution is being presented to them for operational use. This has proven to be a very costly and inefficient approach. Research shows that rework caused by this condition can consume 30 to 40% of the total effort expended on a technology project. Multiple studies have indicated that over 60% of the defects identified on projects can be traced back to errors in the requirements design that were not identified or resolved early on. One analysis of the potential return on investment from better design suggests that a requirement errors can consume between 70 and 85% of all project rework costs. As this graph illustrates, it can cost up to 110 times more to correct a requirements defect after development than it would if that same defect had been discovered during the requirements and solution design phase. It is important that the people who make the decisions have access to known issues and alternatives before a design is undertaken. The involvement of design phase decision makers in due diligence is a characteristic of rapid and agile development that can significantly reduce design costs, increase design acceptance rates, and produce capabilities and solutions with fewer requirements errors at an accelerated rate. When due diligence is conducted, the life cycle of a requirement can be accurately measured, monitored, and improved. The process of developing an initial plan of action and milestones that shows the scope of a problem to be solved before the design phase is considered will provide clear direction. It is also helpful to establish some guiding principles for the effort to help inform agreement on the scope of the assignment and participant roles and responsibilities. For example, is the problem being solved for one organization or an entire cabinet department? Is the planned approach to take small steps or tackle the entire problem at one time? Either way, guiding principles can help fill the gap between direction and collaboration and draw boundaries for participants so that when issues are encountered, those working on the problem know where they are empowered to act and when to escalate. When the direction and guiding principles are identified, the collaboration space that will be required by participants in the design phase will begin to form. For example, depending on the participants or stakeholders involved and their time zones and locations, it may be necessary to use a wide variety of collaboration capabilities that include security classification considerations, online portals or application accesses, in-person meetings and events, phone conference calls, shared correspondence, documents, discussions, blogs, or file folders, delegation and team assignment authorities, escalation paths and chain of command, use of email, blogging, or other public and private digital channels, and internet links and other resources. The last step in the due diligence is to conduct a reality check that shows whether or not you are ready to go. Prior to moving into design, persons assigned to present the results of due diligence should conduct a reality check to ensure they are prepared. Do I know my direction and does it make sense? Is the requirement or request valid and important to the mission? Do I have principles that guide me along the way? Am I organized, resourced, and ready to move forward with design? And do I know who makes the decisions, and do they know me? If you answered yes to all of the above questions, you have completed your due diligence and are prepared to present your recommendation and proposal for the design phase. Upon completion of due diligence, if a recommendation to begin design is going to be made, the person assigned responsibility for managing the design phase will record and monitor the following information where appropriate and brief the decision makers on their recommendation. Project name and objectives, all the results of due diligence, the plan of action and milestones to complete the design bake, including schedule reviews and approvals. A design bake is the final approval of design used to evaluate current capabilities and determine gaps. All project management protocols and all participants and their contact information listed as the project team. If approved to begin design, the design lead will proceed by clarifying the R or requirement using architectures and schedule the design bake with decision makers. In an IMIE, active architectures are used because they are dynamic and continuously informed and shaped by mission requirements, available capabilities, and gaps. Today's IMIE uses a vast array of architectural artifacts and standards to clarify requirements and shape the design. Using an active architecture allows for flexibility because it is informed by approved requirements, shaped by solution designs, and updated as capabilities are added in the context of solutions. This method makes updates to the architectural artifacts continuous and relevant to the current needs. In practice, architectures are applied logically to flush out completed designs. For example, a requirement could be characterized and clarified by describing it as a visualization product that uses a data model inside an application framework to report securely on a trusted platform to enterprise stakeholders. Or, for process automation, the design may follow the path of a BPM product that performs business flows that are collections of common processes that support end-to-end processes to deliver required capabilities to the warfighter. Upon completion of design, if a recommendation to begin development is going to be made, the person assigned responsibility for managing the design phase will brief the decision makers on their recommendation using architectural artifacts they use to achieve the design bake. Generally, when a design is approved, the requirements are evaluated in the context of available capabilities and identified capability gaps, and a course of action is proposed that includes project management, configuration management, an analysis of alternatives, and cost-benefit analysis to deliver the solution. Those steps will be covered in another presentation. During this brief, I discussed the requirements gathering and solution design steps of the IMIE concept of operations that precede the technical capabilities assessment. For more information, please find us in the cloud.